AOT. So how to reduce carrier leakage? So I'm going to use this architecture. So you can see I have a processor which will supply the necessary inputs. I'm going to take the power detector in order to reduce the baseband signal. A of T must be chosen very large. A of T is going to be your actual input signal. So as A of T increases, the input put of up conversion mixer becomes non-linear. Therefore, a compromise is therefore necessary. So as similarly, you have two DACs tied to a transmitter. So I am connecting the two DACs to transmit. Power detector will monitor the output power, and it is digitized and digitized and given to the DACs. And the baseband processor will have its own readings, and both will be compared. Additive means both will be compared. So during carrier leakage cancellation, the baseband produces zero output. So when the carrier leakage is perfectly cancelled, the baseband will produce zero output. So detector measures only the leakage. So it is just like a loop. So you transmit, measure the power, see the leakage, and if the carrier leakage is perfectly cancelled, then baseband will give input as 0, 0. If it is not perfectly cancelled, it will give the coefficients to cancel out the carrier leakage. So it is just like a feedback loop final, and it will ensure that the carrier leakage is made zero. And all the readings are stored in the processor to ensure that a quick turnaround is obtained if there is a carrier leakage in the down conversion receiver. So whatever you transmit, you again take the power data, you again take the sample of that signal, measure the power, and again you do some additional signal processing to cancel out the carrier leakage. So you use an 8-bit DAC. So for an 8-bit DAC, 255, 256 combinations are possible. So totally, you can have 256 for I and 256 for Q. So this product of these two combinations are possible, and system will try all possible outputs to ensure that the carrier leakage is going to be completely minimum. So in this procedure, you can say initially it will start from zero, and as carrier leakage is sensed, slowly the LSB will be incremented by one, and if the carrier leakage is cancelled, it will stop. Otherwise, it will keep on incrementing that to ensure that the carrier leakage becomes zero. It is just like a successive approximation ADC, what we have studied. So gradually, you will be increasing the weight to see that approximate value of the analog signal is obtained. So till you measure the error to be zero, the increment will happen, and once the error becomes zero, the increment is going to be stopped, and we increment by LSB so that the variation in the signal is going to be very, very minimum. We don't do at the MSB, we do only at the LSB.